Welcome to part 5 of Competency 18. In this video, we will discuss prediction errors. Okay, before we begin part 5, let's discuss the model we have for percent prediction error. Okay, as you see, we have a ratio. And in the numerator, you have the measured value, and then you subtract the predicted value, and then you divide all of that by the predicted value. And naturally, to get a percent, you multiply by 100. But just to make all this make sense, let's use an example. Okay, now this example has information given to us, but then the actual question is below. And I'll show you what they're talking about. Okay, it says an educational statistician is conducting a linear model for predicting using the following data. Okay, student A has a final exam grade of 80 and received a course grade of 85, where student B had a final exam grade of 75 and received a course grade of 82. What is the linear equation that best fits the data in the tables below? Not shown. Okay, the tables aren't shown because we're going to drag our information out of this other given uh, question. So, like we're using a question and then asking a question about it. And I'll show you what I mean. So, what they've done is they've taken this data above that's listed about student A and B. So, we're going to use that too. So, go to Stat and see where it says Edit, press Enter, and you put these in each list. So the final grade would be L1 and the course grade would be L2. Okay, so we have 80, enter, 75, enter. Now pop over and put in the 85, enter, and then 82. Okay, now we are going to build the equation that they have here. In the question, it says, "Hey, what's the equation?" Well, we've got it, and I'm showing you how we built it in the first place. Okay, so push Stat and then go over to Calculate. We need the linear regression, lin-reg. Okay, we're building this, so that's number 4. Now, we already have our L1 and our L2 populated, okay? So what we do, you can enter or arrow down, but you want to put that somewhere, okay? So push alpha, trace, and we want it in number 1, okay? Push enter, enter. Okay, that is how you build the model we have, okay? We have the exact same thing here. And if you notice, your A value would be your M slope as we learned in school. Okay. All right. So let's go to our Y equals and notice Y1 is populated. Okay. And that's what we need. That's going to get us our predicted. Okay. So now we go second graph, and I already had it set up to go to 92. Okay, why 92? Let me show you why here. Because that is the final course grade here. So let me read this to you. If student C has a final exam score of 92 and receives a course grade of 83, what percent of error exists based on the linear model? Okay, the Y values are what we are measuring, and you can tell that from the model because notice what we have here. Okay, so our actual value that occurred was 93 for our Y. Okay, but we have to go back and look at our X, which was 92. Okay, so we will set up our model, our situation here, and I'll show you what we had here. Okay, so our predicted is not our given. Our given is 93 That's what actually happened. And then we have to go over here and look and see what do we have. If you had a final grade of 92, you actually had a course grade. Oops. Here, let me scoot all this over. I'm squeezing in too much here. Okay, so what we really have here is 92.2. And then we have to divide all that by 92.2. See if I can give us a little more room. Oh, that's a lot better. Then after we put all that in the calculator, we multiply by the 100 to give us that percent we want. Okay, and remember, these are absolute value here. Okay, all right, so how do we do this? All right, let's back out second mode all the way. Okay, now there's a couple ways you get to absolute value, but probably the fastest is just to use a catalog. So go second catalog, see there, and it's the first one. So just push enter. Okay, but we really want that to be in a fraction setup. So alpha y equals number one. See what I did? I popped it over to the side, then use the alpha y equals, and it put it right where I wanted it, all right? So let's go back up and populate okay, we're going to populate our absolute value. That's the 93 minus the 92.2. Now go down and put in again 92.2. Now we have to arrow over. Remember, we want a percent, so that's times 100. Or if you know just by looking, that's fine too. Now push enter. And that is roughly the percent. Now, yes, it is a small percent. And I would say that we would say that that is almost equal to 7 as a percentage, 0 point, not 7, 0.9-ish percent. It depends on how they want you to state that percent. But there you go. That's about what it would be. However, that is less than a 1% error. So it depends on the error you're looking for or the question asks you about as to if that's a good error or a bad error. Okay, now let's move on and actually start answering some questions. Number one, a student measured the mass of an object to be 187, but the expected mass was 170. What is the student's percent error? Okay, let's put this in the calculator. So alpha y equals. Now, for the numerator, if we simply take the if we simply subtract the smaller from the larger, then we don't need the absolute value, okay? So let's do 187 minus the 170. Now, what do we divide by? Whatever was predicted. Well, in this case, we have the word expected. Well, that means predicted. So divide by 170, push enter. Now for percent, we need times 100. Okay, and there you go. That would be 10%. Option D. Now let's look at number two. A student calculates the density of a rock to be 2.2, and the expected value is 2.7. What is the student's percent error to the nearest tenth of a value? Okay, so let's do the same thing. Alpha y equals number one, and the larger one is 2.7. So then we subtract the 2.2 and go down. Now, the expected or accepted or predicted is the 2.7. So that's what we divide by. Okay, now we need to multiply times 100. And lo and behold, look, that gives us, but be careful. It gives us a value, but not to the nearest tenths. Okay, so be careful. What do we need to do here? Well, that is option C, not A. So when you get two items close like that, go up and look at your question again, just to be sure. Now let's look at number three. Okay, it says a student determines the volume of a cubic crystal to be 7.6 cubic centimeters. Okay, so it's actually a prism, right? The correct volume of the crystal is 7.5 cubic centimeters. Find the percent of error. Okay, so let's go through the same thing. Okay, alpha y equals number one. All right, now the larger one is 7.6. So 7.6 minus the 7.5. What do we divide by? The correct. The correct one implies predicted, okay, or accepted, right? I know that our model said predicted, but for simplification, it's better to explain that as we go instead of putting all those options up there. All right, so that means we need 7.5, and there's a reason why they gave it to us in the second sentence anyway. And when you're taking the exam, that happens sometimes. I noticed that in the second or third sentence, what I needed to do next was given, just flat given to me. There was no assumption. Okay, so push enter. Now we need to turn that to a percent times 100. Okay, be careful. I know I can get rid of D, and I know if I rounded, I could just get rid of C because that doesn't make sense. But now I've got A and B. A is wrong because it terminates. Yes, that is rounded, but let's think about this. What is 1/3? Okay, so let's change that to a fraction. All right, first, to get that to be a fraction, I'm going to say math. See number one right there? That's what I want. And I'm going to enter and enter again. There's my fraction. Now I'm going to change it to a mixed number and see what happens, okay? And you probably already see it. So I'm going to say alpha y equals, and then I'm going to go to number 3, okay? And enter again. And there we go. We could have used number 3 twice also to get that, all right? But we know now that option B is what we need, okay? All right, let's go to number 4. Number 4, a student measured the volume of a piece of a rock to be 25 grams and the expected value is 19 grams. What is the percent error? Okay, expected means predicted, as we stated before. So let's do what we did before. Alpha y equals, okay, enter. So we take 25 minus the 19, and now they've already told us what to divide by, and that's 19. So let's push enter. Okay, now notice that's going to give us a fraction. Even if we multiply it times the 100, we still get a fraction, not a decimal. So what do? Okay, well, we want to push math, go down to number 2, push enter, enter again. That gives us our value, which is option A. Okay. Number 5, a student determined the volume of an object to be 88.6 centimeters. What was her percent error if the correct volume of the object is 0.80? All right, so we do the same thing. Alpha y equals enter. All right, remember, you're taking the larger one, 8.6 minus just 8. You can just subtract 8. You don't have to type all that in. And go down. And the correct volume was 8. So push 8 and enter. Okay, now remember, times the 100, and that gives us our percent, and it's option A. Okay. All right, now let's look at number 6. What would the percent error be if a person predicted that there were 38 jelly beans in a container, but when they were counted, it was found that there was actually 40 beans in the bottle? Okay, so what do? Alpha y equals number 1. So take the larger one of 40 and subtract the 38. What do we divide by? Okay, well, we divide by the prediction right there. That's predicted. That's the model. Okay. And predicted would be what we like our theoretical. Let's say they predicted it because that was their theoretical uh data, like theoretical probability. All right. So let's go ahead and do that. Let's see. So that's 38. Press enter. Okay. Times 100. Remember, we got to do that. Push enter again. But we need our decimal. Fine. That's math. Number 2. And enter again. Now we have something to work with, which we got around. So that looks like we need option C. Okay, that is the last question in this video. I wanted to thank everyone again. You guys are so amazing. So many more people subscribing and sharing and liking the videos. It is so appreciated. And congratulations to those of you who've watched the videos and said it helped and you've passed. You guys are amazing. You're the best. And once again, guys, I wish you all happy testing.